Okay, invite you guys onto the screen share if you can see my screen, hopefully. We're moving on to chapter 12, which is on Entity Framework Core, EF, Entity Framework. And this is a large tool that Microsoft uses to tie in the application to the database. And we've been using it since about chapter 4, but we are going to iterate over what we've learned and build on top. And so if I had a single chapter that was, the most new information, it's probably this chapter. There is a lot of new information in chapter 12, if not chapter 4, right? Chapter 4 was the first time we brought in Entity Framework, and where we just did like CRUD operations on like a single table. But really what's unique about this chapter is we get into all the kinds of relationships, the one-to-ones, the ones-to-many, the many-to-manys. And so in database relationships, that's called your cardinality. And these are what are referred to as normalized databases. Okay, realize we are working in this system of normalized databases versus NoSQL databases. Mongo, that we learned last semester, was NoSQL not normalized, which means at the end of the day, normalization is a process. And that process goes through and you link tables together based on their keys. And so when I was new to this industry, I'm just going through these fundamentals here. Just the word normalization was like a weird word. I didn't quite understand it. So we are working with normalized databases here, and these tables, they all link together through their keys and their foreign keys. And Entity Framework is how you tie in that C# code into the database code. The database code is, the database itself is SQL Server, right? You guys are familiar with this. SQL Server, the edition is called LocalDB. LocalDB is the free edition. So we're tying in our C# into SQL Server normalized database schemas and database tables. And so with this Entity Framework, kind of quickly, we can basically, we're going to do code first development. We've been doing code first development. We're going to continue doing code first development. I have used database first development a small handful of times in my career, so that's an interesting approach as well. So what is the difference between code first and database first? We'll get into a little bit more defining the purpose of the database context and the entity classes. Here, this one, there's 3 techniques to configure your database with code first. Those 3 techniques are your convention, your attributes, and with this syntax called the Fluent API. So we're going to get into those 3 techniques and show you how they look a little different and what they are, whatever. Entity Framework commands right now, you guys have been exposed to the add migration. The add migration command, that is an Entity Framework command. You've also been exposed to the update database command. These are commands that you run in the package manager console, but there are other commands that can, let you work with your database. Again, we're going to go through the types of relationships, talk about foreign keys and navigation keys with one-to-manys and many-to-manys. So one-to-ones, one-to-manys, many-to-manys. We're gonna cover them all. That's those objectives. We're gonna work with the Fluent API. And so once you start having these relationships, then you have some decisions to make. Such as, and we haven't really talked about this much, but they do in this chapter. You can have a genre, and the genre is science fiction. And then you have a bunch of movies that have that genre. Okay? Well, what happens if you have these 100 movies and someone goes to run a delete command against the science fiction genre? You try and delete the parent kind of deal, the science fiction parent, but you have 100 movies that are science fiction. So how do you handle that? And that's what this Fluent API delete behavior. You have options, every application will handle that differently. What are the options, and how do you choose, or how does your application choose to implement that? We'll get into some partial classes in C# and how they might be beneficial to us in this scenario. We will dive a little bit deeper with LINQ, language integrated query. LINQ, you write what's called lambda expressions. These lambda expressions will get translated into SQL to run queries against the database. So we write LINQ. LINQ gets translated by Entity Framework to SQL, and it hits the database. We've written LINQ, right? The where clause, the where method, the select method, the from where select is a typical SQL statement, and LINQ is where from. It's just a different order. It's the same keywords, but they're methods. We'll get deeper into LINQ. We're just going to write more LINQ statements. So we dive a little deeper into LINQ. There are different methods to add a record, to update a record, to save changes. That's all bullet 11 is talking about. What are the methods in Entity Framework to work with database records? Fun word, concurrency. Concurrency is my word of the day. What is concurrency and what in the context of our software? So we'll get into concurrency a little bit. And then bullets 13 and 14. Describe how data access classes can encapsulate code for working with the database and the repository pattern. 13 and 14 are this. Our applications, even in this class, are final projects. Our final projects are what I would describe as a medium-sized scope. It's a medium scope. It's not a small project. You're not whipping up these final projects in a night or even a week. I mean, your final projects, you will have worked on it all semester long. In particular, like the last couple of weeks of this class are just like pure final project work. So they're not small projects. They're also not enterprise level scale. I mean, you don't have thousands of users. You don't have, the demands of enterprise level software. However, in this chapter, we're going to learn some enterprise level scale patterns to bring into our software. So we're going to learn some enterprise level practices and techniques, even though the software that we're writing is not enterprise level. That's what we're going to talk about when we talk about the repository pattern. And on top of it, you guys have already seen the service layer pattern. You guys... I introduced that in the last, what did we do? The auction app. In the auction app, we had the service layer pattern. So I'm going to bring these two things together. The repository pattern, the book doesn't talk about the service layer pattern. However, it should. And so I'm bringing it in. So those are both considered enterprise level patterns that, again, they're not necessary for our software because they're not quite that scale. But these are things that you would potentially see at the enterprise level. And I want to expose you guys to them. Cool. That's a lot of objectives. I'm not kidding you. This is a big chapter of material. I don't think I'm going to hit all the points that I need to in this lecture. This lecture would probably be 6 hours long. Because this chapter is a long one, there's a lot of information. I'm going to do my best to deliver this material in a reasonable amount of time. Yes?
Is it always best practices to do enterprise patterns?
No. I mean, if you have those needs, if I were in your shoes and I were building a piece of software, I wouldn't necessarily bring in these tools unless you, number one, suspect it's going to get that big. Again, tens of thousands of users, teams of developers working on different layers of the software.
So it's like planning for scale.
It's planning for scale. If you're learning, and that's what we're doing, oftentimes this is over engineering. So I wouldn't recommend it for everything that we do in this class. It's just literally, but if you're planning on building a big piece of software, then yes, it would be worth your time up front, and it might save you from refactoring on the backside. Thanks for the question. So we are working with Code First Entity Framework. Code First means you start with C# classes that are referred to as our domain models. You guys are familiar with this language. These are our entities, and these entities tie into database tables, right? So you're familiar with this at this point, and there's a lot of convention that happens here. Notice the book class has a book ID. So class name ID, that is by convention what? What is book ID going to be in the database? It's a database column, but what type of column is book ID? It is a key. Is it a primary key or is it a foreign key?
Primary.
It is a primary key. That is correct. So book ID is a primary key, and author ID is a primary key. And that is automatic. That is called coding by convention. It's the name of the class followed by the word ID, or it could just be the identifier ID as well. For me, I prefer to do the class name ID because I like that extra description. ID is not as descriptive, okay? Now, look at the data type on book ID. Book ID, again, that's called an auto-implemented property. That auto-implemented property has a data type of integer. Okay, what that means is that primary key is known as identity. It's an identity primary key. And all that identity primary key means is that it's set up to auto increment. It's going to start with an ID of 1 and auto increment to 2, 3, 4, and 5. You could set your primary key up with a different data type. Okay, and we've done that in this book. We set up our primary keys to be like, for example, a string. Then in that case, if it's a string data type, it's not an identity primary key, it's just a regular primary key, and it also does not auto increment. Okay, so that's just a couple building blocks for your primary key. So you have the entity classes that ultimately will translate into your tables. The DB context, as I've said this before, is the connection to the database. So DB context is the class that connects to your database. There's a standard class called DB context. If you want to work with the identity system, it's called identity DB context. So the DB class that you create, I think we typically call it application DB context, it inherits from this parent. It inherits from DB context. And you're either inheriting from DB context or identity DB context, depending on if you want the identity user system. And then you have a DB set. The DB set is your tables, right? So this is your table and essentially all the columns in the table. And then books and authors, those are your actual tables. Now notice there's an assignment equal to null. Those are always, whenever the instance of that is created, books are set to empty by default. Just think of all the books it's an empty table is how I think of that. And so you've got the DB context. Again, I just think of that as the connection to the database, and then the DB set is the tables. Now, this is by convention. This is how we are configuring by convention. For example, a string data type. Take a look at title. Notice the data type is string. But there's no string data type in SQL Server. There's an nvarchar, right? So there's a conversion between data types. In C#, we're calling it a string. In SQL Server, we call it nvarchar, variable length characters. Var is variable length, chars, characters. N represents Unicode encoding system, so that every character takes up 2 bytes, I want to say, 16 bits. Okay, so every character in the database takes up 16 bits of space. The thing about Unicode is that it supports all the languages of the world. So that's the N on the N varchar in the database. However, convention is just one way that you can configure entity framework. There are other ways. Those other ways are by data attributes. We've done data attributes with validation before, even though we kind of use them. We don't use them because we use fluent validation more. But if you had a auto-implemented property that wasn't by convention, you wanted to name it something different, you wanted the column to be named something different, you could mark it as a primary key, right? You can mark it with the key column. So those are attributes. You've seen attributes before. And that's another way to configure entity framework. The third way, and the most code-centric way of doing it, is with the Fluent API. The Fluent API is a bunch of methods built into entity framework that allows full control of all the data types, all the table names, all the column names, all the relationships. You can code everything using Fluent API. Point is, Code First Entity Framework can be configured with all 3 of these approaches. There's no one solution, and many times you're using multiple solutions. Okay? I'll give you an example. For me, again, you might be different. For me, I code a lot by convention. I just like the automatic, because I understand the convention. I like to code by convention. However, I'll give you a scenario where I have to use the Fluent API. If I have a many-to-many table and I want to see data in my tables of my many-to-many relationship, you pretty much have to use the Fluent API to see the data. Okay, so there's scenarios where I use a lot of convention. I probably use the least of the data attributes. And there are scenarios where I have to use the Fluent API because that's like the only way that I know. Not saying there might be other ways that I don't know. But basically, I used convention and Fluent API in my code demos because that's the only way I know to do it. Some tasks. Okay, here's another task that I only know how to write, like the Fluent API. We're going to talk about delete behavior, cascading deletes, and the like. I have to set up my delete behavior with the Fluent API because I think, to my knowledge, it's the only way to do it. So some tasks can only be done with the Fluent API. Okay. I already talked about bullets 1 and 2. The third little piece here is that realize that these data types, integers are not null by default. Strings by default are nullable in the database. But decimals and ints are not nullable. Unless you put that little question mark on the data type, decimal. And then guess what? Your database design changes. If you put a question mark on decimal, then that all of a sudden that column, that price column, will allow nulls in the database. So realize by changing the entity classes, you also change. So ints or doubles are not nullable by default. That means the column in the database table is not nullable. So these are just some methods of the Fluent API. The one that we've definitely used already is has data. You guys have seeded. In your database context, there's a method called on model configuring or on model creation. On model creation, we call this has data to seed data. But you can change relationships. using, you could set up keys using the Fluent API. You can set up primary and foreign key relationships. You could set up required. So even though maybe you legitimately don't want in C#, you might not want the decimal to be nullable, but for some reason you want to use the Fluent API to change that, you could do that. You could set up maximum length. So by default, nvarchar max allows users to type in as many characters as they want. You might not want to allow the users to type in as many characters as they want. You could use the maximum length, the string length attribute, or you could use hasmax length and then specify a number of characters there. So there's different ways of doing the same task. Right, so this is configuring that same on-model creating method that you guys are familiar with. This is configuring the book table to have a required title field using Fluent API and a maximum length of 200 characters. So you can kind of develop your opinions. Here's a little bit more where we're setting up a primary key. We're setting up that same line as we saw before, and we're seeding some data, right, using has data. So this Fluent API is coded in the DB context. Most of the time, it's going to be in this on-model creating method call. Now the book makes a point that you might want to basically not have this much. The DB context makes the connection to the database. If you start filling up your DB context class with all this other database schema, this is setting up your database schema. And so if you start putting kind of like database schema definitions, too much of this in your DB context, you might decide to put that somewhere else. And in this case, they're making a class called bookconfig, a method called configure where they put that code, and then inside of the on-model creating, you just call that class model builder apply configuration new book config. So book config was the class we made here, and then all we're doing is then applying that book config. So it keeps your DB context clean and minimal. Okay, so that's going to be a reoccurring thing in this class. Get the logic somewhere else. Put the logic somewhere else, Single purpose separations of concerns. That's right. So these are all Entity Framework commands to work with your database schema. The ones that we've used many times in this class: add migration, update database. Add migration will look at your classes and update the database and create a migration file with your database schema in it, and then update database runs all of your migrations. So you can have multiple migrations, and then update database will change your database schema to match the migration files. If you add a migration file one at a time and you realize you made a mistake, you might remove that migration. So you might add 3 migrations. Remove migration just removes the last migration. There's also a remove migration with a number 0. Remove migration 0 basically resets your database schema completely back to nothing, no database schema. So remove migration 0, I believe that's the correct command. Let me double check that I'm not making a mistake on that. Remove migration removes the last migration. The third, update database applies any migration that hasn't yet been applied to the database. We got that. Drop database deletes the database. Script migration. Right now, we're doing this on our development machines. Script migration will actually generate a SQL script, a .sql file. So if you need to run this that's not in a dev environment, if you need to create the database from a SQL script not in a dev environment, the script migration command will generate a .sql file. And you could generate that database outside of your developer box. Scaffold DB context is the command for database first entity framework. And so what that command does is it'll look at the database tables and the database relationships and the keys. It'll look at the database tables first if the database was already created, and it will generate the C# classes for you. It'll generate the domain models. The domain models is the word I was looking for. So we're primarily doing code first entity framework. This command here is a database first entity framework. And again, it just depends on the environment you're in. If there's already a database there and you're trying to make an application to interact with that database, you might start with database first entity framework. Okay, and they all have switches, right? So add migration, you might give a custom name, or what directory do you want to put it in? By default, it puts the migration in a migrations folder, but it doesn't have to. You could change the output directory. Same thing, your update database command could run a particular migration if you pass in the /name. Otherwise, it just runs the latest migration. And then these are all the switches for that script migration command. Again, that's not a command I've had to run. I'm always doing the development box. And this just goes through a process. You add a migration, you change the database, you change your entity classes, you add a new migration, and then you run the update database command again, add migration command again, and then update the database. You guys already did this on a hands-on test. You had multiple migrations, I think, on your second hands-on test. So you've seen that before. Migrations folder. He's like, wait a minute. I don't want that discount. So you can revert the changes from add discount on your database, and then you can remove the file. So this reverts the database to the prior schema, and then this removes the migration anymore because you don't want it because you decided that's not what you want. Someone blowing me up? Discord? Or is that one of you guys?
I think it's the show.
Got it. Here's update database 0. Was that the command I said, update database 0? Did I get that right? Yes. Update database removes all the migration files from the migrations folder. Enter remove migration repeatedly or manually delete all the migration files from the migration folder, including the snapshot. So it reverts, this reverts your database schema back to like non-existence. So if you just want to like start over, there's other ways of doing this. Like if you just delete the migrations folder, delete the database, does the same thing. Again, multiple ways of accomplishing the same goal. Okay, again, this is moving on to the types of cardinality, the types of relationships, and you just got to say, hey, you always just got to ask a question. You got two entities in the real world. What's their relationship to one another? One to many. One user can have many orders, but an order only has one user. So that's it. That's a one-to-many relationship. One-to-one. The interesting thing about one-to-one, and I didn't realize this right away, one-to-one relationships are always considered optional. You don't have to. You don't have to have one-to-one tables, but it forces one user can live in one state. I don't know if that's a good example because it doesn't go that way the other way. Let me think of a one-to-one. I don't do many one-to-ones, so none of these jump out. What's a one-to-one? I don't do many one-to-ones.
Just a general example of a one-to-one.
Yeah, let's ask. What are classic examples of one-to-one in database?
The book has an example.
What's the book example?
Author, like if an author is only related to like one author bio.
One author can have one author bio, and that one author bio only belongs to one user. You could just put author bio as a column in the author, could just be a string inside of the author table. That's why I say they're optional. A user can have only one user account setting. An employee has their own sensitive data table, so you might not even want to put the social security number and the salary in the employee table. You might have a separate table for that. That's interesting because that a little bit more security on this table obviously would be needed. One citizen could have one passport. Okay, these are all valid examples of one-to-ones. Many-to-many. The one that we're going to do, and this is kind of a continuation of the book, of the example in the book. The example of many-to-many in the book is an author can have many books, and a book can have many authors. So an author, again, one author can write 100 books, and then any individual book can have multiple authors. I mean, our book right here has 2 authors, right? So that's a many-to-many relationship. How these are configured. A one-to-many relationship is configured by putting a list on the side of a one. So a genre can have many books. A genre can have many books. So notice we have a list of books. Now they use an I collection because it doesn't have to be a list. It could be another collection type. It doesn't have to be a list. And then on the book side, a book has a single genre. So it's a one-to-many relationship, and that is coding by convention. Could you configure this by attributes? Yes, you could. Could you configure this with the Fluent API? Yes, you could. What do I prefer? I prefer by convention. That's just my personal preference. Now, if you wanted to configure it by attributes, 2 attributes for doing that is the foreign key and the inverse property. So there's a foreign key column which would belong on genre ID. And I believe the inverse property would go on the navigation property of the genre itself. So this is how you code by convention. These two properties are how you would code by attributes, these two attributes. And they would be configured with the Fluent API with this method called hasWith. HasWith would be used to configure book and genre. Here's an example of using the Fluent API to configure a one-to-many. So notice what we're doing is on model creating. We're still in that same method. We're looking at the book entity. And it's called the hasWith because you're chaining methods. So it's has one. A book has one genre. That's your navigation property. With many genres, genre.books. So it's has method and the with method. And you start with the current entity. This is a lambda expression. The book has one genre. The genre has many books. And the book has a foreign key of genre ID. So that is an example of using the Fluent API to configure a one-to-many relationship. Now, what is easier? Convention? This is convention, or the Fluent API. I think convention is easier, but that's not to say that that's what you have to do. I certainly understand some people like to go under the hood, dig under the hood, write the code under the hood, and I totally respect that, and I get that, and I've done that. But a lot of times when you're teaching, I like the simplistic answer. There's author and author bio. There's some noise out there?
Yeah. Somebody's having a
That's loud. We did a one-to-one relationship early on in this class. I don't do a ton of these. What's worth pointing out here? Primary key navigation property. Primary key. Foreign key. What is there worth pointing out? It's a one on this side and it's a one on this side. There's no list of anything here. See this? I mean, that's all that's really worth pointing out is that there's a navigation property. These are both navigation properties, and there's no list of author here, and there's no list of author bios here. These are just ones, and then the author bio has the author ID as the foreign key. Has its own primary key, and then here's a standard foreign key. So they're not that hard to code. I just don't code them that often. And this would be a way to make sure, this would be like a hard way of enforcing that the author ID is both a primary key and foreign key. This would make sure that you do not have duplicate author bios. That would that would enforce the one-to-one relationship. And so this would be a better way of configuring it, to be blunt. So again, you could do it by convention, you could do it by attribute, which actually provides a slight benefit here, or you could configure one-to-one with Fluent API. You kind of get the feel for this? Attributes, Fluent API, or by convention. Okay. Let's take a quick break. All right, we'll go ahead and resume. When it comes to my experience in databases, like you guys, I started learning databases in college, and I took 2 database classes, and that database class, I learned a little bit about the process of normalization. And in the process of normalization, you get it into what's called third normal form. Have I mentioned this before, 3NF? No? Third normal form is considered a normalized database. So you got first normal form, that's the first step, second normal form, third normal form. And there's a few steps at each layer, but third normal form is considered good enough for production. So you want your database tables in third normal form. And if I had to, let's see if I can list the steps of database of 3NF. So these are all the steps that you must take to get into first normal form, to get into second normal form, and then get into third normal form. So things like identify a primary key, repeat repetitive groups, eliminate duplicate columns. To get to second normal form, you got to do this, plus you need to remove partial dependencies, create separate tables, and then so on and so forth. And kind of like this one, separate into new tables, moves the transitively dependent columns into their own table, leaving a middleman column as a foreign key column in the original table. So these are the steps that it can take. So when it comes to database design and you're designing a database, I would encourage you to look up the steps of third normal form, dig deeper, figure out, how to get it in third normal form. But one of the rules, of getting it into normal form is that a many-to-many on paper in design should not exist. What you do is you break up your many-to-many relationship with a middleman. That's kind of what I think that this was talking about here. With this middleman. So on paper, you do not have a direct many-to-many. Instead, what you do is you create a one-to-many between a middleman. This is a new table. And so by convention, your book has a list of authors and your author has a list of books. That's the many-to-many on both sides. What Entity Framework Core does is it will automatically make a third table called author book. Okay, and so what you have is you have a one-to-many between book and author, and you have a one-to-many between author and author book. So this new table has a primary key that is a compound primary key. These two columns together become the primary key, and they're both dependent on the foreign key as well. So the name of this table is author book. You could kind of see where that comes from. The name of this class and the name of that class combined together. So author book is the name of the table. Author's author ID is the name of this column. Books ID is the name of this column. This is a compound primary key. The two of those values together come together to make up the primary key, which enforces the uniqueness, and they're foreign key columns as well. Okay, if I could say it more concisely, many-to-many relationships are broken up. Many-to-many relationships are broken up into two one-to-many relationships with this new table that is a middleman, that is called a linking table, or you might hear it called a join table. It's got a couple different names I've heard it called. In this code example here, I've done just that. And if I were to show you the database, what did I even call this? This is many to many. What did I call this database? Give me just a second. Called it bookstore. So here's bookstore, here's tables. Here's my author, and here's my book. And then here's the middleman, author book. So my book was seeded with 3 books, book ID 1, book ID 2, book ID 3, The Shining, Harry Potter. Okay, so there's my 3 books. The author has 3 authors, 1, 2, and 3. And then the join table, author 1 wrote book 1, author 1 wrote book 2, author 2 wrote book 2, and author 3 wrote book 3. So that's how you combine those together, and this is how you seed that, right? So Stephen King, Peter Straub, J.K. Rowling, The Shining, Talisman, Harry Potter. So this one says Stephen King wrote The Shining, Stephen King wrote The Talisman, Peter Straub wrote The Talisman, and J.K. Rowling wrote Harry Potter. So this is how you seed data for a many-to-many. Again, the convention is table name, plural, primary key. Authors, author ID. Books, book ID. So there's a little bit of convention there. And like it shows there, generates the table called author book. It will be a requirement of you guys to have a many-to-many relationship in your final projects. That many-to-many will need the linking table. So this will definitely be something you guys do. I'll do this code demo in a little bit more detail because there's more layers to it. Now that's by convention. You could also do it by attributes. So here's the book. So you could do it by attribute. You could also code many-to-many relationships by the Fluent API. Again, has with, right? The has method and the with method to kind of traverse through that. Now, what's nice about this, what's nice about using the Fluent API is if you wanted a more specific table name, if you don't want to use the conventional table name or the conventional column names, that's where Fluent API comes in handy. You don't have to just take the default names for the tables and the columns. With Fluent API, you could set the table names for that join table. Yeah.
So without Fluent API, is it just always a concatenation of the two?
It's a concatenation of the two. Yeah. Yeah, by convention. And I showed how to do that seed data. So this is kind of doing it all together, right? This is Fluent API configuring the relationship first between the many-to-many relationship and then seeding the data next. Okay. Now that we're dealing a little bit more with these different kinds of relationships, a conversation needs to be had around a very common error that developers will have if we're just doing CRUD. Again, a genre can have many books, right? So it's a one-to-many relationship. And so the parent in that case would be genre. And then you got a bunch of books that have that genre. And so what happens when you go to delete the genre? You got an end user, and that end user wants to delete the genre. A cascading delete could be very problematic. A cascading delete would not only delete the genre, but it would delete all the books that have that genre. Okay, so for sure, cascading delete is the most dangerous because you delete all the children that have that parent row value. I highlighted this in my book. Page 466, by default, code first development, which is what we're doing, configures a foreign key with cascading deletes if the foreign key is not nullable. So if I were to go into my models, not nullable here. So if I were to look at the columns and let's view the designer. Okay, this does not allow nulls. So these guys do not allow nulls. So these foreign keys do not allow nulls. And according to here, code first development configures a foreign key with cascading deletes if the foreign key is not nullable. So kind of the default behavior here is pretty dangerous, right? If you were to delete one author, then all the books that author wrote also get deleted. So you don't want that. I would not recommend cascading deletes. I would recommend restricting. What restrict does is it throws an error. And that says, hey, you cannot delete genre because there are books that have that genre. You must first delete the books. If you delete all the books that have that genre, then you can delete the genre itself. Okay, so restrict is what I would recommend for these scenarios because you don't want to delete a genre that has dependencies. I think restrict is the safest answer for sure. The other answer is like, hey, you delete the genre and then the genre ID just becomes null in the children. So that's called orphaned, like you orphan these children, which is not also a good thing. You know, null values are not very descriptive. They're not very good, right? So how do you configure the delete behavior? You configure the delete behavior with Fluent API. It's a one-liner of code, page 467. You set the on delete behavior restrict. It's a pretty simple one-liner line of code using Fluent API. Okay, so cascading there is the default. You don't want that. You want to set it up to restrict. There's also a whole demo that I need to give you guys on optimistic concurrency. Optimistic concurrency is a simple concept. I don't know where the word gets its origins. I don't know exactly what it is, where the origins come from, I should say. But what optimistic concurrency is let's just say that Nia and Michael, they both want to edit a book. And Nia edits the book's title and changes the book title and then clicks save. But then during Michael's edit, he still has the old book title on his computers in his working RAM. So that when Michael goes to edit, I don't know, the book date that it was published or whatever, he goes to edit another field and he clicks save, that could potentially overwrite Nia's edit of the title. Okay, so that would be problematic. And so what you want is you want what's called optimistic concurrency. You want, in this case, in that scenario, Michael should receive an error. Okay, and that would essentially mean the first one to click save. Nia, in this case, Nia would save, and then Michael would get an error saying, "Hey, this record has changed. Please refresh the page and try again." And then when Michael refreshed the page, he would see Nia's new title in his web page, and then he would update whatever other field he went to update. Okay, so optimistic concurrency and delete behavior, these are things that you want to configure on your software in .NET MVC because they're the safer options. And these are just things we have not talked about. And optimistic concurrency is not quite as simple to code as cascading deletes. Cascading deletes is a Fluent API one-liner. Optimistic concurrency is done with try catches. So what you need to do is you need to throw an exception when Michael goes to save his changes because their changes have happened on the database record. So that needs to trigger an exception. That exception needs to be caught with a catch block and stop, and basically give the end user instructions to refresh the page. So there's a little bit more code involved with optimistic concurrency, and it does involve a few more steps in that. That's why I need a demo around optimistic concurrency. I need to show you guys in a coding demo, and I will do that. Okay. So we talked about all these relationships, one-to-ones, one-to-manys, many-to-manys. We talked about delete behaviors. We talked about optimistic concurrency. A couple more concepts left. So this is, again, there's a lot in this chapter, and I'm just trying to hit the high levels. That is link. Now, when it comes to link, you guys are all familiar with what these are referred to as lambda expressions. The letter here represents the entity, in this case, where the book's price is greater than $10. So it's book arrow, that's your entity, and then the book's price greater than 10. There's an extra arrow in there. And then you select, again, the book entity where the book's, you select the book title. So give me all the book's titles where the price is greater than 10. Link can be used against databases. Link can be used against arrays and other collections, other data sets. Link could be used against C# objects. And so notice, I guess there's two things I'm going to point out here, and we're going to hit them a little bit deeper. There's multiple ways to write link, and this is the method syntax. Okay, the method syntax is what we're going to use. And there's also a couple of interfaces. There's two main interfaces that you have to dive into just a little bit when dealing with link. And those two interfaces that are important are IEnumerable and IQueryable. Okay, so there's a little bit of difference between those two interfaces. So I'm going to talk about both of these things, the method syntax and these interfaces, in a little bit more detail. Okay, so when it comes to link, high level concepts is that there's like an older syntax called the query syntax, and there's a newer syntax called the method syntax. Okay, you might see link written in this query syntax. That's not what's recommended. That's not best practices. You can see here the industry standard for Entity Framework is using the method syntax. Okay, so just number one, being aware that there are multiple syntaxes. Link is very similar to SQL. SQL is select from where. Those are your keywords in SQL. Select from where. Link is where, typically from, and then select is the last one. But select is not mandatory. If you don't select certain fields, you select all of the columns. Same keywords, different order is what it boils down to. When it comes to those two important interfaces, you can build a query without executing that query. And so if you have an interface, you can build a query as a pending database query. Why this is important is because if you build this query, and you could do a lot of filtering on this query, you don't need to store as much in your RAM, in the client's RAM. And so so when you're looking at a variable and that variable's data type is iQueryable, this is just building a link query. The query isn't actually run until you call there's a couple ways to materialize a query. One of the main ways is calling the toList method. When you call the toList method, or you can iterate over, that's another way of materializing it. That's how you materialize an iQueryable variable. IEnumerable, though, that is after the query is run. So when you run the query and you store that data in IEnumerable. To enumerate over something just means to loop over it. So I think of that as your list, right? You've got a list of entities now at this point. So IEnumerable represents data already in memory. If you run the query too early before you filter records, you'll pull all the more data than you need to in RAM, and then you can perform filtering there and says this is a recipe for a crashed application. You don't want to pull all the database records if you have thousands, or sometimes you could have millions of records, and a single computer can't handle, like a laptop can't handle that much information. So you want to build out the query, and then you execute that. You execute the query calling toList, and then you store the results of that in IEnumerable. And then two of the main methods that we've worked with in Link, and this is to kind of traverse through your relationships, is include and then include. Include and then include, this is the equivalent of SQL joins. This is joining tables together, but instead of joins, that's SQL. Joins are in SQL, and then including is within Link. So again, include is the equivalent of joining another table, and then you do then include, which is used for drilling down multiple levels. So if you're in the orders table, you need to include order details and then include product. You guys remember projections from Mongo? I know Mongo was a long time ago, a little bit. In Mongo, we had something called aggregation pipelines, where you build queries kind of in stages, right? And one of the last things we did is we did a projection. And so if you have a database record, it comes out and it might have 50 fields on it. You might have 50 fields on this database record. You don't want to select all 50 fields. Just give me the customer's first name, last name, and street address. You would project those 3 columns, and then you would have a custom object that was only first name, last name, and street address. So a projection is where you take an object out of a database, and instead of having all 50 fields, you have a subset of fields. Okay? So that's very normal, and in fact, I do that I've done a projection in one of my coding demos from a while ago. You guys will see it again. Kind of like a view model, but you're taking it out of the database, and yes, it's kind of like a view model, but a view model, it's very much like a view model. It's very much like a view model. In fact, that's kind of where I'm going with this. So when you create a projection using Link, you do that with the select. I think it says that in here. See here? You select the fields. If I go back here, No. I guess I don't really have an example. But to create a projection, you use the select method. So instead of selecting the whole customer, you select the customer's first name, customer last name, select the customer first name, select the customer last name, select the customer address. That's how you create a projection. And you can say, like, see here, selecting, you can do this anonymously. And anonymously is like, hey, it's kind of like JavaScript. It's not like a var. It's like, hey, you just put it in this data structure. It's an anonymous data structure. But C# isn't, it's a strictly typed language. It's not a loose type language. So most developers don't like anonymous types. In fact, if you take an anonymous type, okay, so you run a link query against a database and you store it in an anonymous type, and then you were to pass that to the view, which is where the view model comes in, that would crash. You can't pass an anonymous type to a view. And so they have this concept of a data transfer object where you give your projections a solid type, right? Your projections are given a solid data type called a DTO, a data transfer object. And then what you do is you take that data transfer object. A data transfer object is a C# class created to hold and transfer a subset of data, in this case from the database to the view. So yes, they're very much. In fact, let's dig a little deeper, because compare and contrast view models and DTOs. They're both used to carry data between different parts of a system. They serve very different masters. What do you mean by masters? Think of a DTO as a shipping container for travel, while a view model is the storefront. So the DTO is efficient data transport. And that makes sense, right? Instead of having all 50 fields of a customer, you just got the 3 fields that you need. The view model is very specifically for a UI or a view. Now the book, it's confusing because the book takes the DTO and sends it to the view. That's where the confusion comes in. So location, between layers, API to the service or the database to the API. So in here, they're not taking the DTO in this example and sending it to the UI. But the book does that. And I think that's the problem with, I don't think the book has the best example. So if you think about a DTO, it's transporting data between like your API to your service layer or your database to your API layer. So it's not going all the way to the view. The view is the view model, the data that goes to the view. Yeah, you don't want to put sensitive information. A DTO is a dumb object used to group together so it can be sent on a single call. Its main job is to reduce the number of trips between a client and a server between different microservices. Use a DTO when you're sending data from your database to your API controller. Use a view model when you need to display data on a web page. Again, view model is pretty straightforward. What do you need in the view? What data do you need in the view? A DTO is just, I think of a DTO as sending data around your application to different parts of the application besides the view. Okay. So again, it's kind of a newer concept, this concept of a DTO. And the last thing here is just an introduction to these enterprise patterns. So took some notes. Says we will build our apps to mimic large enterprise software best practices. This includes dividing responsibilities across a service layer and a repository layer. Okay, so we have to learn what goes on at each slice of the layer. So the repository pattern. The repository pattern is specifically for database logic. So the repository's purpose is to hide the complexity of the data access. Your application shouldn't care if the data is coming from a SQL server, a JSON file, or an external API. The repository handles that. So again, it's working with the data. So what it does, gets by ID, add method, deleting, working with listing. You're working with the data at the repository layer. So the benefit of the repository layer is if you switch from SQL Server to MongoDB. You guys have learned both. Okay? If you switch from one database system to another and you have a repository pattern, you don't have to refactor the whole application. All you have to do is refactor that individual layer. You just have to refactor the repository code, not the entire application. So the goal is to decouple the application from whatever database system you're working with. If you're working with Entity Framework and the like, it creates a layer of abstraction that it doesn't matter your data source. It can work with all sorts of data sources. And so it's hard to work. The more abstract the concepts get, the harder it is to like conceptualize and understand the code, because it just becomes more and more abstract. It gets a little bit hard to work with. However, the understanding doesn't necessarily come from the definitions. The understanding, I think I think it'll start to click the more you code it. Okay, so the repository is where you're working with your data access. Okay, the service layer is where you put your business logic. Okay, so when there are business rules, like, I don't know, at Rankin, a student can only take so many amount of loans. I'm just making something up, right? So any individual student can only have $40,000 worth of loans, just making up a number. Okay, if that's a rule to Rankin, where do you put that business logic? And if you look at this book in chapter 4 says, put that logic in the controller. That's what chapter 4 says. And in chapter 4, that's where you should put it, because there's not many options. Okay. However, there's a real place, in enterprise level code, where should you put business logic? And the answer is the service layer. So business rules like Rankin students can only have $40,000 worth of loan. That belongs in the service layer. Data validation. We use fluent validation. Well, right now our fluent validation is done in the controller. So if you're putting your business logic in the controller, that's what's called a fat controller. Okay? Controllers really should just work with your HTTP requests. Controllers really, at the end of the day, they should be getting HTTP get, HTTP post, HTTP puts. You guys are familiar with those HTTP methods. That's what controllers should do. Controllers should route traffic. That's what controllers should do. If you have business logic in your controller, that's not the right place. If you have database access code, like getting all of the customers or updating the customers, that's not the right place for that. That's a repository pattern. You put it in the repository. So when you take that stuff out, your controllers get pretty lean. So if I go into one of my controllers here, and again, we're going to code this demo next week. Like, our controllers are pretty lean. There's not a ton of code in our controllers. Right? We're making a view model. We're calling a method on the book service. The service, we'll get into it. The service layer is on top of the service layer sits on top of the repository. But you can kind of see our controllers, the methods in our controllers don't have as much code because we've taken a lot of that out. Okay, so again, our controllers route requests. The service layer is our business logic, like fluent validation. The repository deals with the data. We're going to have what I call a quality of life update. You guys play video games, and in video games, they have quality of life updates. So there's some utility classes that the book introduces that are just quality of life utility classes. So we're going to introduce query options classes. These are just library classes, utility classes. And then we actually have the database itself, which is the warehouse. And what this allows you to do when you have all these different layers, it allows you to test the layers individually, right? So as we get into unit testing, which there is a chapter on unit testing in this book, when you have everything divided up so nicely, you could test each individual layer of the stack. Okay? So realize here, there's a lot underneath the hood here. I just wanted to introduce these concepts, these layering concepts in this chapter, and then I think it's going to start to click as we do some coding demos, which are coming around the corner.
So we're going to do like an enterprise lab.
That's the idea. Yeah, your final projects will implement these.
Okay.
Your final projects will have enterprise level architecture. It will be a requirement of them. All right. That brings us to the end of that lecture, so I'll stop